From the table on the left, we are to find first the probability that 3 or more copies will be demanded in a particular day, and second, the probability that demand will be at least 2 but no more than 6. We write the first problem into the probability of x that is more than or equal to 3. Since we are looking for the probability of 3 or more copies, we can then add the corresponding probabilities of copies 3 to 10 highlighted in the table. The probability that 3 or more copies will be demanded in a particular day is 0.64. Similarly, the second problem will also be based on the table. Just now, we have to look for the probability of x that is more than or equal to 2 but less than or equal to 6. Adding the highlighted probability of 2 to 6 copies, 2 should be the least and 6 should be the most. We will then get the probability of 0.52.
Let's proceed with item number 2, and with this problem we have the probabilities of a machine manufacturing and defective parts in one day. We will be needing the value of the random variable, the probabilities of the random variable x, and the mean of the probability distribution. So we have here our table with the values of our x, 0 to 5. In our next column, we have here the values of our probabilities. Taking steps on finding the mean, we have to multiply both probability and the values of our random variable. So we have here the lineup of our numbers. And then we add up these Niña as x times px, and we have here 0.39. In other words, the mean of the probability distribution is 0.39.
In this problem, we are looking for the mean of the probability distribution. To solve this, we first have to plot values into our table, with the x column signifying the number of boxes delivered each day, and the p quantity x column referring to the probability of the number of delivered boxes each day. Now, to fill up our third column, we have to multiply the values in the first and second column. After multiplying, we have to add all the products to get our mean. The answer is 37.1. The mean of the probability distribution is 37.1. To answer the question, yes, it is believable. It is a believable claim since the value of minimum deliveries per day is 35 boxes.
In number 4, the number of computers sold per day at a local computer store, along with its corresponding probabilities, is shown in the table. Find the variance in the standard deviation of the distribution. To organize and find the variance in the standard deviation, in the first column in the table, I listed all of the numbers of computers sold as x. Then in the next column are the probabilities of the random value x. In the next column, we will multiply the random value x and p of x. After that, we will get the summation or the mean of the answers in the previous column, in which it is 1.77. In another table, the first column contains the answers of the random value x and the mean squared in the next column and multiplied to p of x. In the last column lies the variance 2.4184 and squared, which will be 1.551, the standard deviation in the problem.
For item number 5, the number of inquiries received per day in Stack Senior High School is shown in the table. Now we are going to find the variance and standard deviation of the given data. So in order to do that, we are going to find the values under these columns of the table for us to arrive with the variance and standard deviation. So for x, which represents the number of inquiries, we have here 22, 23, 24, 25, 26, and 27. And for p of x, which represents the probability of number of inquiries, 0.08, 0.19, 0.36, 0.25, 0.07, and 0.05. For the next column, we are going to multiply x and p of x. By then, we'll get these values. With the solved values, we can now get the summation of x multiplied by p of x, which is our mean. It is equals to 24.19. Next, we are going to subtract the mean to our x. We'll get these values. Next up, we are going to square these values. We'll get these values. Next, we are going to multiply the prior values to the p of x. We'll get these values. This time, we are going to find its summation for us to arrive with the variance. Using this formula, we'd get 1.4539. Therefore, the variance is equals to 1.4539. For the standard deviation formula, we're going to find the square root of the variance. We'd get 1.206. Thus, our standard deviation is 1.206.